Your factory-spec Ford is a ticking time bomb, and your owner's manual is the fuse. You bought into the marketing. You bought the Built Ford Tough legacy, thinking that 40 years of best-selling truck history meant your garage was safe. You think because your truck sits high and pulls hard, it can survive the routine neglect that kills lesser vehicles. You are dead wrong. The reality under your hood is a war zone of tight clearances, extreme thermal loads, and bean counter engineering. Ford builds highly capable machines, but they engineered them on a razor-thin margin of error. If you follow standard consumer habits, or, worst of all, trust the dealership's inflated light-fine maintenance schedules, you are actively accelerating your vehicle's trip to the scrap yard. We are pulling back the curtain on the 5 fatal maintenance mistakes Ford owners make every single day. These aren't rare edge cases. These are the exact mechanical failures that keep independent shops profitable year after year. Setting 5. The EcoBoost Oil Delusion. You are treating your twin turbocharged EcoBoost like your grandpa's naturally aspirated 1995 small block V8. That is a 5-figure mistake. The marketing promised you V8 power with 4 or 6-cylinder fuel economy. They delivered on the power, but they hid the thermal cost. When you push a 2.7-liter or 3.5-liter engine to produce massive torque at low RPM, you generate astronomical cylinder pressures and intense localized heat. The bearing journals inside those turbochargers spin at over 200,000 RPM. The only thing preventing catastrophic metal-on-metal friction is a microscopic film of oil. When you follow the onboard oil life monitor and stretch your intervals to 7,500 or 10,000 miles, you destroy that oil. The extreme heat of the turbocharger housing cooks the fluid the moment you turn off the ignition. This process, called coking, turns standard engine oil into hard, abrasive carbon deposits. If you use cheap conventional oil or the wrong viscosity weight because it was on sale, you accelerate the slaughter. Modern EcoBoost engines require strict full synthetic oil meeting Ford's WSS M2C946B1 specification. Cheap oil lacks the shear stability to survive the brutal mechanical thrashing inside the variable cam timing (VC) phasers. The tiny oil passages feeding the cam phasers plug up with sludge, dropping oil pressure below the critical 15 psi required at hot idle. Once that pressure drops, your timing chains stretch, your phasers rattle, and your turbo bearings self-destruct. Consider the math. You save $30 by buying cheap oil or skipping an interval. Your reward is a $4,500 bill for a twin turbo replacement, or a $6,000 bill to fix a mangled timing set. The actionable fix: dump the oil life monitor. Change your EcoBoost oil every 5,000 miles maximum, or every 3,000 miles if you tow frequently. Use only premium full synthetic oil that strictly matches Ford's viscosity and specification rating. Never let a quick lube shop pour generic bulk oil into your turbocharged engine. Setting 4. The silent acidification of your cooling system. You ignore your cooling system because your temperature needle sits right in the middle of the gauge. You assume everything is fine until steam pours out from under your hood. That ignorance is dissolving your engine from the inside out. Modern Ford V8s and EcoBoost platforms operate under intense thermal stress. They rely heavily on aluminum cylinder heads and complex multi-layered steel head gaskets. The coolant flowing through these passages does more than drop the temperature. It carries a chemical package of corrosion inhibitors, designed to protect the bare aluminum from cavitation and erosion. Those inhibitors have a strict lifespan. Over time, heat cycles break down the chemical compounds, and your coolant turns acidic. Once the pH drops, the fluid becomes an electrolyte. An actual electrical current begins flowing through your engine coolant, a process known as electrolysis. This acid attacks the thin aluminum walls of your heater core, your water pump impeller, and the sealing surfaces of your head gaskets. You can't see this damage from the outside. You can't feel it. But while you drive, the acidic fluid is quietly eating away the metal sealing ridges around your cylinders. When the barrier finally fails, it happens instantly. A high-load event blows the head gasket, forcing combustion gases into the cooling jacket and warping the aluminum cylinder head beyond repair. Let's look at the financial stakes. A cooling system flush costs roughly $150 in fluid and tools. A warped head and blown head gasket on a modern 5.0-liter Coyote V8 will easily drain $5,000 from your bank account. The actionable fix. Pop your hood every month and check the coolant color and level in the reservoir. Do not just top it off with tap water, which introduces destructive minerals. Flush and replace your cooling system fluid every 3 years or 50,000 miles using the exact factory-specified Ford fluid, regardless of what the 100,000-mile owner's manual claims. Setting 3. Direct injection and the fuel octane trap you by a premium EcoBoost vehicle. Pull up to the pump and select the cheapest 87 octane fuel available. You think you are outsmarting the system because the gas cap says regular fuel acceptable. You are falling straight into a trap that builds massive carbon restrictions in your intake tract. Ford's EcoBoost engines utilize direct injection. This means fuel is sprayed directly into the combustion chamber at pressures exceeding 2,000 psi, rather than upstream in the intake port. When you run low-octane 87 fuel under high load, your engine wants to detonate. The NOx sensors detect this pre-ignition instantly and force the engine computer to retard the ignition timing. This stops the engine from blowing itself apart, but it severely increases exhaust gas temperatures and alters the combustion cycle. Because the fuel sprays directly into the cylinder, the intake valves never get washed by fuel detergents. Instead, oily vapors from the positive crankcase ventilation (PCV) system bake directly onto the blistering hot backs of the intake valves. When you combine the elevated temperatures of low-octane fuel with these oily vapors, you get heavy, rock-hard carbon buildup. Within 60,000 miles, this carbon chokes the intake ports, restricts airflow by up to 30%, and causes chronic low-speed pre-ignition (LSPI). This results in rough idles, random misfires, and a massive loss of low-end torque. You think you are saving $8 per tank at the pump. In exchange, you lose 10% of your fuel economy, choke out your horsepower, and pave the way for a specialized walnut shell blasting service that costs over $100 to clean the valves. The actionable fix if you drive a turbocharged EcoBoost. Feed it 91 or 93 octane premium fuel, especially if you tow or drive aggressively. Install a high-quality oil separator or catch can on the PCV side of the engine to trap the oily vapors before they ever reach your intake valves. Setting 2. The sealed for life transmission Liu bought into the biggest marketing myth of the 21st century, the lifetime transmission fill. Ford tells you the fluid inside your complex 10R80 10-speed automatic transmission is good for 150,000 miles. This is an absolute corporate fabrication designed to lower the perceived cost of ownership for fleet buyers. No fluid is immortal. Inside your transmission, clutches are constantly slipping and engaging, creating immense shear stress and microscopic friction material wear. Your transmission fluid undergoes brutal heat cycles, reaching temperatures over 220 degrees Celsius in heavy traffic or during towing. Under these conditions, the vital friction modifiers in the fluid break down completely. The fluid oxidizes, turns black, and loses its ability to lubricate the tightly toleranced valve body. Once the fluid degrades, the internal hydraulic valves stick. Your shifts become harsh, the torque converter clutch begins to shudder, and the planetary gear sets run on depleted protection. The 10-speed automatic is a mechanical marvel, but its clearances are so tight that even minor fluid degradation leads to total unit failure if you wait until 150,000 miles to change that fluid. The fresh detergents will actually wash away the remaining friction material holding your worn clutches together, slipping the transmission into total uselessness. You save a couple $100 by ignoring the transmission fluid during your first 5 years of ownership. Your penalty is a complete transmission failure that requires a total rebuild or replacement, costing between $7,000 and $9,500. The actionable fix: ignore the 150,000-mile service interval completely. Service your Ford automatic transmission by performing a fluid and filter change every 45,000 to 60,000 miles. Ensure the shop uses the exact Mercon ULF or specified fluid for your exact model year. You think these 4 mechanical landmines are bad? You think a destroyed turbo or a melted transmission is the worst-case scenario for your driveway? The absolute worst design flaw. The one that has plagued Ford engines for decades and continues to evolve into an even more expensive nightmare today is something most owners don't even discover until their engine starts destroying itself from the spark plugs outward. You are completely blind to what is happening inside your ignition system right now, and the consequences of ignoring it make a broken transmission look like pocket change. Setting 1. The ignition coil and spark plug death spiral. You treat your spark plugs like a set-it-and-forget-it component. You read that modern iridium plugs can go 100,000 miles, so you leave them buried deep inside your aluminum cylinder heads for a decade. You are playing Russian roulette with your engine's entire electrical architecture. Ford has a notorious, decades-long history of spark plug engineering failures, from the infamous thread-stripping Triton V8s to the brittle, two-piece plugs that broke off inside the head. While Ford finally fixed those specific physical thread designs, the modern issue has shifted from a mechanical extraction nightmare to a catastrophic electronic chain reaction every single time your engine runs. The microscopic gap between the spark plug's center electrode and ground electrode widens due to spark erosion. This is basic physics. As that gap expands beyond factory specifications, often swelling from an optimal 0.03 inches to over 0.055 inches on high-mileage engines, the electrical resistance increases exponentially to jump that massive eroded gap. Your ignition coils have to work twice as hard. The Engine Control Module, ECM, commands the coil to step up the voltage, forcing it to generate upwards of 40,000 volts instead of its designed 25,000 volt threshold. This extra voltage creates intense internal heat within the coil's copper windings. Eventually, the insulation inside the ignition coil melts. The coil shorts out, causing a dead misfire. On a naturally aspirated engine, a misfire makes the truck run rough. On an EcoBoost engine, a misfire boost is a lethal event. The unburned fuel from that dead cylinder gets shoved straight into the exhaust manifold, where it hits the white-hot turbine wheel of your turbocharger and the precious metals inside your catalytic converter. The fuel ignites instantly inside the exhaust system, spiking temperatures past 900 degrees Celsius. Consider the financial reality. A set of 6 or 8 OEM Motorcraft spark plugs costs you around $60 to $90 and takes an hour to install. If you ignore them and trigger this death spiral, you will blow through a $300 set of ignition coils, melt a $2,200 catalytic converter, and potentially overheat the turbo housing, resulting in a total repair bill that easily clears $3,500. The actionable fix: do not wait for a check engine light or a stutter under acceleration. Change your spark plugs every 60,000 miles on naturally aspirated Ford engines, and every 30,000 to 45,000 miles on all turbocharged EcoBoost models. Always use a calibrated gapping tool to verify the gap matches the factory spec exactly before installation, and apply a high-quality anti-seize compound to the threads to prevent galvanic corrosion with the aluminum head setting 0. The variable cam timing, VCT, solenoid starvation. You assume that as long as your oil level is somewhere between the two dots on the dipstick, your engine's internal valve train is perfectly safe. You treat oil purely as a lubricant. You are completely blind to the fact that inside a modern Ford engine, oil is also used as a high-pressure hydraulic fluid. Modern Ford architectures, especially the 3.5-liter EcoBoost and the 5.0-liter Coyote V8, rely heavily on variable cam timing VCT systems to constantly adjust valve timing for performance and emissions. This system is controlled by VCT solenoids, which act as hydraulic valves, routing pressurized engine oil into the cam phasers to advance or retard the camshafts. The tolerances inside these VCT solenoids are measured in microns. To prevent debris from jamming these hypersensitive valves, Ford installs microscopic mesh screens inside the oil feed passages when you run your oil down by just 1 quart, or when you use oil that has degraded and begun to shear down. You introduce microscopic bubbles, a process called oil aeration. This aerated, frothy oil cannot maintain hydraulic pressure. Worse yet, as degraded oil creates microsludge, these tiny particles instantly clog the microscopic mesh screens, feeding the VCT solenoids. Without a flawless, high-pressure stream of clean oil, the VCT solenoid starves. The cam phaser loses its hydraulic lock, and begins violently slapping back and forth against its internal mechanical stops every time the camshaft spins. You will hear this as a distinct, metallic rattling sound on a cold start. If you ignore that rattle, the violent mechanical slapping will shatter the plastic timing chain guides. Once those guides break apart, the slack timing chain will jump teeth on the gear, instantly throwing the engine's timing out of sync. Because these are interference engines, the pistons will slam into the open valves at 3,000 RPM, completely destroying the cylinder heads and bending the connecting rods. Let's look at the economic stakes. Keeping your oil topped off and clean costs pennies. Replacing a set of clogged VCT solenoids costs around $800. Allowing those solenoids to starve and destroy the timing components results in a catastrophic internal engine failure that requires a complete engine replacement, costing between $9,000 and $13,000, the actionable fix. Check your oil level manually at the dipstick every 2 weeks. Never rely solely on the digital dashboard warning lights. At the absolute first sign of a cold start rattle or a delayed throttle response, have a technician scan for VCT-related diagnostic trouble codes, such as P0011 or P0012, and replace the VCT solenoids and screens immediately before the timing chain suffers permanent stretch, the unspoken setting. The EPAS electronic steering death sentence. You think your maintenance responsibilities stop at the engine bay and the drivetrain. You focus entirely on fluids and filters. Ignoring the massive electronic chassis systems that keep your vehicle on the road, you are completely ignoring the electronic power-assisted steering (EPAS) gear sitting directly underneath your front axle. Ford pioneered the widespread use of heavy-duty electronic steering racks in full-size trucks and SUVs to eliminate the parasitic drag of hydraulic pumps and boost fuel economy. The EPAS system uses a high-output electric motor bolted directly to the steering rack, controlled by its own dedicated computer module that communicates constantly with the vehicle's main data bus. Because this unit sits at the lowest point of the chassis, it is exposed to a brutal barrage of road debris, salt, water, and extreme vibration. Ford protects the internal ball screw mechanism and the electronic motor housing with rubber dust boots and perimeter seals. Over time, these rubber boots degrade, crack, or get torn by road debris. The moment a boot tears, moisture and road salt are sucked directly into the internal mechanical gears and the electronic motor chamber. The water corrodes the internal sector shaft and shorts out the sensitive electronic circuit board inside the steering module. The failure doesn't give you a polite warning. You will be driving down the highway at 70 miles per hour, and the EPAS system will suddenly drop into total hard fault failure mode, completely cutting off all steering assistance and instantly logging a steering fault service now message on your dash. The steering wheel will immediately become incredibly heavy to turn, creating an incredibly dangerous handling emergency, because Ford integrates the motor, the module, and the mechanical rack into one single, non-serviceable, sealed unit. You cannot simply replace a damaged sensor or a shorted motor. The entire assembly must be torn out and replaced. The math is brutal. A visual inspection of your steering boots takes exactly 30 seconds during an oil change and costs nothing. Replacing a completely failed, moisture-ruined EPAS assembly requires specialized programming tools to align the new module to your truck's VIN, racking up a bill between $2,200 and $3,500 at a qualified shop, the actionable fix. Every single time your vehicle is up on a lift or you are changing your oil, take a flashlight and physically inspect the rubber bellows boots on both sides of the steering rack. If you see any signs of tearing, cracking, or grease leakage, replace the boots immediately to keep moisture out. Ensure your vehicle's battery and alternator are operating at peak health, as low voltage fluctuations are a primary cause of electronic steering module communication corruption. Setting -1. The blind spot monitor water trap you. Focus all your defensive maintenance on the mechanical components underneath your hood. You check your oil, you monitor your coolant, and you watch your dashboard gauges like a hawk. You think you have covered every base. You are completely oblivious to the fact that 2 tiny plastic boxes hidden inside your rear bumper are waiting to trigger a total electrical blackout that will leave your vehicle completely dead in your driveway. Modern Ford vehicles, especially higher trim F-150s, Explorers, and Edges, rely heavily on a high-speed digital communications network called the Controller Area Network, or CAN bus. Think of it as the central nervous system of your vehicle. It allows the engine computer, the transmission module, the body control module, and all safety systems to talk to each other in real time. To power the Blind Spot Information System, BLIS, and Cross-Traffic Alert, Ford mounts radar modules directly inside the rear quarter panels or behind the rear bumper corners. These modules sit right in the direct line of fire for water, mud, slush, and road salt thrown up by your rear tires. Ford enclosed these sensitive radar computers in plastic housings with simple foam gaskets. Over 5 or 6 years of driving, these gaskets dry out, shrink, and split. The moment that gasket fails, the radar housing transforms into a literal fishbowl. Water fills the module, submerging the active circuit board. Because these modules are wired directly into the vehicle's critical high-speed CAN bus network, the water doesn't just short out your blind spot warning light. It sends a massive, chaotic electrical short straight into the main data network of the entire vehicle. When that data network shorts out, the vehicle undergoes a complete electronic nervous breakdown. You will walk out to your vehicle, press the start button, and absolutely nothing will happen. Or worse, while driving down the road, your dashboard will light up like a Christmas tree. Your instrument cluster will go completely blank. The transmission will drop into a fail-safe limp mode, and your wipers will start wiping uncontrollably. The network is flooded with corrupted data, and the engine computer can no longer confirm that the key is present or that the transmission is in park. The diagnostic nightmare this creates is legendary. Independent shops will spend days chasing phantom codes, replacing perfectly good body control modules or ignition switches, while the true culprit sits dripping wet inside your rear bumper. Consider the cost breakdown. A regular inspection and a simple bead of silicone sealant around the module housing costs about $10 an hour of your time. If you let it flood, you are on the hook for 2 new radar modules at $600 apiece, plus hours of advanced electrical diagnostic labor and network reprogramming, running your total bill to over $2,000 for a safety feature you barely think about, the actionable fix. Do not wait for your dashboard to lose its mind. If your Ford is more than 4 years old, slide under the rear bumper with a flashlight. Locate the BLIS radar modules behind the rear body panels, unbolt them, and inspect the housings for moisture or corrosion. Clean the electrical connectors with dedicated electronic contact cleaner, reassemble them, and apply a thin, defensive bead of marine-grade silicone sealant around the housing seams to lock out moisture forever. The final warning. The EcoBoost vacuum pump oil leak catastrophe. We have reached the absolute summit of deceptive engineering flaws. The single most overlooked, misdiagnosed, and deeply destructive maintenance failure in the modern Ford lineup. This is the ultimate hidden landmine, and it affects the millions of 3.5-liter and 2.7-liter EcoBoost engines currently occupying American roads. You think an oil leak is just an annoying spot on your concrete driveway. You think as long as you add a quart of oil every now and then. A small leak at the back of the engine is something you can safely put off until you have extra cash. That casual assumption is actively preparing to burn your vehicle to the ground because turbocharged engines do not create natural intake manifold via come under boost. Ford had to engineer a mechanical solution to provide vacuum for your power brake booster and wastegate actuators. They bolted a mechanical, camshaft-driven vacuum pump directly to the very back of the cylinder head, buried tightly against the firewall where you can barely see it. This vacuum pump is fed directly by high-pressure engine oil from the valve train. To seal this high-pressure connection, Ford used a simple rubber O-ring subjected to the intense, trapped thermal energy at the back of the EcoBoost engine bay. That rubber O-ring completely loses its elasticity within 60,000 to 80,000 miles. It turns brittle, cracks, and begins blowing a steady stream of highly pressurized engine oil out of the back of the pump. Because the leak is at the absolute back of the block, the oil doesn't just drip cleanly onto the ground. It drips directly onto the blistering hot turbos and the catalytic converter exhaust downpipes, which routinely reach temperatures exceeding 700 degrees Celsius under normal driving conditions. At first, you will only notice a faint, sweet burning oil smell through your cabin vents when sitting at a red light. But as that O-ring degrades further, the pressurized oil begins to pool in the insulation shields surrounding the exhaust. Under a high-load situation, like towing a trailer up a hill or accelerating hard onto a highway, the exhaust temperatures spike, passing the flash point of the engine oil. The oil ignites instantly. Because the fire starts at the back of the engine bay right next to the fuel lines and the main wiring harnesses, the engine bay transforms into a raging chemical furnace within seconds. By the time you pull over and step out of the vehicle, the entire front half of your investment is completely consumed by fire. If you take your vehicle to a generic shop, they will look at the front of the engine, tell you your valve covers are seeping, and charge you for a repair that doesn't fix the true danger. Let's look at the financial stakes. The replacement factory O-ring costs exactly $6. The labor to pull the pump and swap the seal takes about 2 hours. If you ignore that burning smell, you trade a $6 piece of rubber for the absolute, total loss of your vehicle to an unextinguishable engine fire that your insurance company may fight you to cover, the actionable fix. If you smell even a faint hint of burning oil inside your cabin, do not drive another mile without investigating. Take an inspection mirror or your smartphone camera, reach all the way to the back of the passenger side cylinder head against the firewall, and check the bottom of the mechanical vacuum pump. If you see even a single drop of fresh oil or wet residue on the exhaust heat shields below it, park the vehicle immediately and replace that vacuum pump O-ring or the entire pump assembly before you turn your truck into a roadside bonfire. The master maintenance blueprint. You cannot rely on corporate promises or dealer-driven maintenance schedule (ES) to protect your machine. If you want your Ford to survive past the 200,000-mile mark and deliver the legendary durability it is capable of, you must execute your own strict maintenance protocol. Let us review the definitive, non-negotiable fixes that stand between your wallet and the scrapyard. The EcoBoost lubrication rule. Forget the 10,000-mile monitor. Dump your oil every 5,000 miles maximum using top-tier full synthetic oil that strictly matches Ford's factory viscosity specification to save your turbo bearings and cam phasers. The cooling system schedule. Flush and renew your coolant every 3 years or 50,000 miles with genuine Ford-specified fluid. Do not let acidic fluid eat your head gaskets from the inside out. The fuel octane mandate. Run 91 or 93 octane premium fuel in your EcoBoost to lower combustion temperatures. And install a PCV catch can to completely stop intake valve carbon choking. The drivetrain preservation. Disregard the sealed for life transmission myth. Service your automatic transmission fluid and filter every 45,000 to 60,000 miles to keep the tightly toleranced valves shifting smoothly. The ignition lifetime. Replace your spark plugs every 60,000 miles on naturally aspirated engines and every 30,000 to 45,000 miles on EcoBoost models to prevent ignition coil burnouts and catalytic converter meltdowns. The hydraulic Valvetrain lock. Manually check your dipstick every 2 weeks. VCT systems require absolute full oil capacity to maintain the hydraulic pressure that keeps your timing chain from snapping. The chassis shield. Inspect your steering rack rubber boots during every single oil change. A $30 torn boot will instantly ruin a $3,000 electronic steering assembly. The electronics lockdown. Seal your rear BLIS radar modules with a defensive bead of silicone to prevent a total CAN bus electrical system blackout. The ultimate fire prevention. Inspect the back of your cylinder heads for vacuum pump oil leaks. Fix that $6 O-ring before it drips onto your hot exhaust and burns your vehicle to the ground. Your vehicle is a highly precise, heavily stressed piece of engineering. Treat it like a high-performance machine. Reject the manufacturer's lazy